Good afternoon, my dear students. Welcome to our class in science. Okay, so we're going to review first our lesson last time about resultant force. Okay, so we have here vocabulary words, but let's read our objectives for this lesson. Students are able to spell and pronounce the vocabulary words correctly. Okay, so we have here vocabulary words. Let's read number one. Okay, number one, resultant. Everybody read resultant. Number two, force. Number two, force. Number three, spring balance. Spring balance. Number four, magnitude. Magnitude. Number five, direction. Direction. Number six, diagram. Diagram. Number seven, exert. Exert. And number nine, number eight, measure. Measure. Okay, so you've already copied this one last week on your science notebook, right? Okay, so resultant. 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 So resultant. The resultant force is the single force that has the same effect on the object as all the individual forces acting together. Okay, resultant. This is just a review, right? We already tackled this one last week. Next word, force. Everyone, let us read force. 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 So, example sentence, a force is a push or pull acting on an object. The same you see in the picture, push and pull. Okay, next word, spring balance. Let's spell spring balance. Springbalance. Spring balance. Okay, so example, we use a spring balance to measure force. So as you can see here, you can see this one or you see this object. This is what we call spring balance. Spring, right? Spiral. Spring. Next word, magnitude. 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 Okay, magnitude. The length of an arrow shows the magnitude of the force acting on an object. So, look at the arrow. So you can see tail, direction, and head of the arrow. So we call this one as magnitude. The longer the arrow, the higher the magnitude or the greater the magnitude. Next word is direction. Direction, spell Direction. in direction. So, example sentence, we use an arrow to show the direction of the force acting on an object. So, direction, we use an arrow to show direction. Okay, next word is diagram. Diagram. D I A G R A M. Diagram. Example sentence, draw an arrow in the diagram above to show the force of Q on P. Okay, so you see on the picture, these are the example of diagram. Like this one, bar graph, right? This is an example of diagram. This one, pie graph. And also this, called it diagram. So next, exert. Exert. Let's spell exert. E X E R T. Exert. Example sentence. Who is exerting a greater force? Brian and Alyssa or Daniel and Maria? So here you can see on the left side, Brian and Alyssa exert 10 Newton and Daniel and Maria exert 12 Newton. So who exerts greater force? So here we can see on the right 12 Newton. On the left side 10 Newton, meaning Daniel and Maria exert more or greater force. Okay, measure. Let's spell measure. M E A S U R E. Measure. So, force is measured in Newton. Newton. So, look at this picture. Two people exert their effort to pull the person, right? So this one, this yellow shirt boy exert 450 newtons and sky blue shirt exert 450 newtons. So if you add 450 plus 450, we can have 900 newtons all in all. So they pull a total of 900 newtons. So, resultant force. The objective, students are able to understand the concept of force. And students are able to know how to get resultant force of the object. So, it's just a review. Let's go to our next presentation. Okay, here. Okay, introduction to forces. What do you see on the picture? You can see two cars, right? Two cars. Or here, this one is a jeepney. And this is a car. Okay, where do they come from? How are they measured? How are they added? And subtracted. Okay. What does motion have to do with forces? Okay, you'd be surprised at how closely these two concepts go together. Suppose I ask you to move a heavy disk in the classroom. How would you move it? Get on one side and start pushing, or you can grab the legs and start pulling. Either way, you would be using force. What is force? A force is a push or pull. Change the motion of all objects. Anytime you see something moving, you can be sure that a force created its motion. Okay. Force are everywhere. Without force or without forces, sports, dancing, driving, basically everything would be impossible, right? Everything would be impossible without force. You use force every time and everywhere, even when you walk. ใช่ไหม You use force when you eat, when you watch TV, when you run, when you read, when you write. You use force, right? Okay, some forces like weight are present when things are not moving. Types of forces. So we have here types of forces. Number one, contact force. Contact force created between two touching objects. Example, like holding a pencil, hugging someone. Okay, created between two touching objects. Holding a pencil or hugging someone. That's example of contact force. Contact force. Now, how about gravity or gravitational force? Gravity, force of attraction between two objects. Example, Earth's gravity pulls on all objects. Okay? Earth's gravity pull on all objects. Number three, friction. Friction. What is friction force? A force that resists motion between two surfaces that are pressed together. Okay, look at this picture. As you can see, number one, the ground produces a contact force on the skater as she pushes against the ground. Okay, contact force. Number two, gravitational force or gravity pulls the skater towards the ground, right? Everything has gravity on Earth. Number three, there is friction between the wheels and the ground. Okay, friction between the wheels and the ground. Friction. Looking at this picture again, there is another force present. What is it? Oh, normal force. What is holding the skater up? The ground. It is called the normal force. So we have another type of force. It's called normal force. It is the support force exerted upon an object which is in contact with another stable object. For example, if a book is resting upon the surface, then the surface is exerting an upward force upon the book in order to support the weight of the book. Okay, that is what we call normal force. If we put the book on the table, okay, if we put the book on the table, it's called normal force. Okay, next. Units. Newton, or we write as N. Okay, and 1 Newton accelerating a 1 kilogram object at 1 mile per second. 1 meter per second. 1 meter per second. 1 pound is equivalent to 4.448 newtons. Okay, don't forget 1 newton accelerating 1 kilogram object. Okay, forces have magnitude and direction. Forces have magnitude and direction. We already tackled magnitude and direction, right? We have these words in our vocabulary. Magnitude and direction. Like velocity, force is a vector. Force is a vector. That means it has size, magnitude, and direction. Magnitude, the amount and strength of the force, measured in Newton. So force is measured in Newton. Okay, next. Force vector example. Okay, look at this example. A smaller force of 5 Newton would have a small skinny arrow. Okay, look at this picture. Soccer ball kick. Okay, 5 Newtons only. You can see thin or skinny arrow that indicates a 5 Newtons only. Okay, smaller force. Now, on the other side, on the right side, you can see a larger force of 500 Newton. Look at the truck. Would have either a long arrow or a thick one. Okay, look at this truck. Big jet truck traveling at 376 miles per hour. So it's bigger, right? Use thicker arrow or longer arrow. If you compare this arrow to 5 Newton, you can see the difference. Small arrow or thin arrow, and you can see thick arrow or a longer arrow because it has a greater force, greater Newton. Okay, balance force or balance forces. Look at the picture. Look at these basketball players. Okay, they have the balance force towards the ball. Okay, net force. If the force is balance, meaning it has 0 or it's 0 newtons. No change in motion because they have balance or they have equal force. List 3 examples of balance forces. Okay, paper on desk. You in the chair. You sit on the chair. It's balance force, right? Plug not moving. A plane or car moving at speed, constant rate or speed. Okay. How about unbalance? Unbalanced force. So look at this picture. You can see that the force of 2 basketball players are not balanced. So the other side, on the left side, you can see smaller force. Then on the right side, this basketball player wearing white jersey He's exerting more force, right? You can see that one in here. It's obvious that he's exerting more force than the black jersey colored player. Cause a change in motion. Possible to add the force together to find the size and direction of the net force. Okay. Also, this example, this is unbalanced force. On the left side, you can see girl, and on the right side, you can see the boy. The girl exerts 25 Newton going to the right. The direction of the force is going to the right. And the boy pulls the piano, also going to the right, only 20 newtons. So if you add 25 newtons plus 20 newtons, we can have 45 newtons to the right. The direction of the piano is going to the right. Okay, so here you can see if the forces are moving in the same direction, add forces. Add means addแปลว่าบวก right? Okay. Example, girl pushes 25 newtons to the right. Boy pulls 20 newtons to the right. So, net force 45 newtons to the right. The piano will move to the right. Oh, look at this. Unbalanced force. Another example of unbalanced force. If the forces are moving all opposite directions, subtract the force. Opposite direction. Okay, don't forget, if the forces are moving in opposite direction, subtract the force or minus, right? Subtract or minus. Dog number 1. So here is the dog number 1. Pulls 10 newtons to the left. Dog number 2, this one, pulls 12 newtons to the right. Okay, you minus or you subtract 12 minus 10. 12 minus 10 equals 2, meaning the rope will go to the right because dog number 2 is bigger or exert more effort compared to dog number 1. Okay, also this one. Okay, so this one is bigger and this one is smaller. So if this truck will push these bricks or this wall, it will exert more effort compared to the smaller truck, right? Okay, so next time, we're going to calculate this force. We're going to try to calculate this force. Okay? When we meet again on Thursday, I think. Oh no, on Friday. Oh no, it's not on Friday. It's on Wednesday. We're going to meet on Wednesday. We're going to calculate this one. Okay? And that's it for our science subject. Okay, thank you for listening to teacher. See you next time. Bye-bye.